All right, so we are doing Chapter 8, Section 6 today, which is solving rational equations. I think that you will find that this section is not quite as hard as the previous section. It does involve, part of it, the most complicated part, does still involve finding the least common multiple, but hopefully with these two sections, you're starting to understand that a little bit more. If you do understand that, then these sections should not be that difficult with a little bit of practice. So let's just go ahead and get started. The front page, I think, is super easy. It brings back a concept that you guys have learned many years ago, it seems like, probably 7th and 8th grade. We're just kind of twisting it with a little bit more algebra than what we used to. So start with some vocabulary, and this is what you should be used to. Cross multiplying is a technique used for solving simple rational equations for which each side of the equation is a single rational expression. Okay, and then the other one is going to be an extraneous solution, which we've said over and over again. Now remember, extraneous means the solution that does not work. Does not work. It must be rejected. Okay, extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation. Okay, so let's just get into these examples. The first set is both of these that you see here, they're both rational functions. So all we're going to do to solve these is we're going to use proportions. We have two fractions. We can use the idea of cross multiplying and setting them equal to each other. So that means that 3 times the quantity 4x plus 5 will equal 9 times the quantity x plus 1. So then we just go through and solve. You distribute both sides. We have variables on both sides, subtract, do all the algebra that we've learned how to do in the past to get x equals -2. So that's one example for you. So let's go through this example together right here. Same idea. So we do 20 times x minus 2. And understand, this is true for any type of rational functions or fractions. If you have one fraction on each side of the equal sign, then you can always cross multiply. Now, if we have more than a fraction, then we're not going to be able to do that. It has to be a single fraction on each side for you to be able to do this. So on this side, we have 5 times the quantity, 3x minus 5. And then all we do is distribute. So we have, here's 20x minus 40. This is 15x minus 15, or sorry, minus 25. And then we solve. So you can, obviously you don't have to do it this way. You can, you can do it however you want to solve these. It doesn't mean that you have to really subtract 15x from both sides first, but that's what we'll do is we're going to subtract 15x from here. So 20x minus 15x is 5x minus 40 equals -25, and then we add 40 to both sides. We get 5x equals 15, and then we're going to divide each side by 5, and we get x equals 3. And then you can plug these back in to make sure they work. So 20 divided by 4 is 5, and 5 divided by 1 is also 5. Okay, so once you get your answer, make sure you plug it back in and make sure that it works. So again, all we're doing is cross multiplying. This is not cross multiply and divide. This doesn't work like that. It is cross multiplying, setting equal to each other. That principle only works when we're dealing with numbers only and just one missing variable. Because we have expressions, it's just simply 20 times x minus 2 cross multiplying equals 5 times 3x minus 5, solving from there. Okay, do these two on your own over to the right and go ahead and hit play when you're ready. Okay, so this first one, you should have gotten x equals -4 as your answer, and when you plug that back in, it does work, so that is your solution. The second one, you should have gotten x equals -5. Again, look at the work that's here. It's pretty self-explanatory with the cross multiplication and setting equal to each other and then solving. Hit pause if you need to jot it down, but other than that, we're going to move on. You can let me know later if you have questions on that. So let's move on. So moving on, this is a little bit more complicated, but this is where we get into the same thing that we've been doing in the last section, which is finding LCDs and using LCDs. because sometimes we have something like this. We're trying to solve an equation, but we can't add and subtract because we don't have a common denominator. So what we're going to do here is the same idea. We want to look at what we have, and we first want to find the LCD. Once we have the LCD, we're just going to multiply both sides by that LCD so that way it gets into a form that we want. Because what's going to happen is when you multiply both sides of an equation by the LCD, you're going to eliminate everything on the bottom of whatever fraction we have. The point of this is to eliminate the fractions. So that way we just have a, one equation that we need to solve. So here you have 1, which the bottom of that is just 1. Here we have x minus 5. And then we have x. Well, the least common multiple of x minus 5 and x is just x times x minus 5. That's what you see here. Okay? So what you do then is you're just multiplying both sides by that, and you just multiply it normally. So x times x minus 5 times 1 is just x times x minus 5. And then on the other end here, we're multiplying it by this one, but you're noticing the x minus 5 and the x minus 5 will cancel out. So we're only left with 8x. And that's where that 8x comes from, is because this x minus 5 and this x minus 5 cancel out. Please don't forget, this just doesn't cancel out and then you don't have to do it. You still have to multiply it. That's why this is here. Okay, and then on the other side, same idea. You see quantity x minus 5 is our LCM. This x right here and this x right here cancel out. Cancel out, cancel out, so you're just left with 3 times x minus 5. And then from there, you go through and solve the problem. It turns into a quadratic, you factor it, and then you find your solutions from there. And again, I'll let you walk through that on your own as needed. Let's just get right into the example that we have. So in this case right here, the 2, that's irrelevant when we're trying to find an LCM because the bottom of that would just be 1. We have an x plus 3. We have another x plus 3, but we don't need to repeat that. And we have an x minus 4. Therefore, our LCD, or lowest LCM, doesn't matter, is x plus 3 and x minus 4. So that's what we're going to multiply both the top and the bottom by. Okay, so that's what we're going to do here. We do x plus 3 and x minus 4. We do x plus 3 and x minus 4. Okay, so on this first one, if you notice this right here, okay, this is going to be multiplied across the top. So whatever's on the bottom and whatever's on the top can cancel out. So therefore, our x plus 3 and x plus 3 here cancel out. So all we're left with is x minus 4 and 3x plus 5. On the other side, we're going to get x plus 3, x minus 4 times 2. So we're going to get 2 and then x plus 3. And we don't have to multiply any of this stuff out yet. We'll do that later. And then over here for the second one, the x plus 3 and x minus 4 are going to cancel out with both of these. So all we're left with is plus 8. So this and this cancel out. Again, make sure that you multiply by the 2 first to get this term, and then they cancel out on the second term to get plus 8. So now what we can do is we can multiply these out and try and solve. So this will be 3x squared, and again I'm just foiling this. Make sure you foil correctly. Minus 7x minus 20. And then over here we have, and again I'm just skipping right to the simplified version of it, 2x squared minus 2x minus 16. Then we bring everything to one side, set it equal to 0, and try and solve. So when we bring everything to one side, we get x squared minus 5x minus 4. And if you were to try and factor this, you would find that this cannot be factored. So therefore, whenever you can't factor something, you do one of two things. You either, 1, use the calculator to solve, or use the quadratic formula. Okay, so you can use one or the other to figure out what your values there are. And I have the values. You have a positive 5.702, and x also equals a negative 0.702. Okay, and you check those back into the original equation, and you find out that these are indeed the solutions. Okay, so again, all you're doing is finding the LCD first, then you're multiplying the left and the right side of the equal sign by the LCD, so that way you can eliminate what's in the bottom of whatever fractions you have. Just make sure you multiply through the entire thing and leave what doesn't cancel out. Okay, so once you get there, solve it. Most likely, not all of them, but most of them you will get quadratic, some of them you won't. So go ahead and try these two, and then just go ahead and hit play when you're ready. Okay, so for this first one, you should have gotten x equals 2. Your LCM here was 4x. Again, we didn't need to repeat the 2 because 2 already goes into 4. So if you said that the LCM was 8x, that's okay because you probably still get the right answer. The one good thing about doing this is that when you do your LCM or LCD, if you don't get the least common multiple or the lowest common denominator, if you just multiplied everything, you would still get an answer because all of our answers here, you're getting an actual solution. So don't worry about that too much. When in doubt, just literally multiply all three of them. But anyway, we got 4x here. So what we did was we multiplied every single term by 4x to cancel out everything on the bottom. The 4 and the 4 canceled out, the x and the x canceled out, and the x and the x canceled out, and we ended up getting x equals 2 for this. Only one solution here. Down below, the lowest common denominator or multiple was x times x plus 2, basically just multiplying these two. And again, I multiply every term by that. So x quantity x plus 2 times 1, x quantity x plus 2 times 4 over x plus 2, and then our x plus 2 is canceled out there. And then we had x quantity x plus 2 times 9 over x. The x is canceled out. And then again, all of our fractions are now gone. We're left with a quadratic, which we then bring everything over to the left-hand side to equal 0. Factor it, but please remember that when you factor, you still don't have your solutions. When you factor x minus 6, x plus 3, that does not mean that your solutions are negative 6 and positive 3. Make sure that you understand that this is going to be positive 6 because that's what makes it 0. This is going to be negative 3 because that's what makes it 0. So our two solutions, which both work, are x equals positive 6 and x equals negative 3. So that's it for this section. I will obviously help you guys with whatever you need help with tomorrow. So see you then.